well, I'll think of something here in a bit. So, all right, exponents, okay, exponential functions, growth and decay, kind of what we were doing before. So there's a couple of things we know about an exponential function. Okay, number one, the exponent, which is kind of weird to us, we're used to it being a number, is going to be x. Okay, that's one thing right away that lets us know, ooh, this is going to get big, because I can plug any number in, not just 2 or 3 or something like that. The other thing that I learned is that this equation that goes with it, which is called y equals a times bx, okay? The b value is what's really important here, but a is my initial value. How much did I start with? Whether it's money, bacteria, you know, the value of a car, whatever it happens to be. But then b tells me if it's growth, if the value is bigger than 1, or if my graph is going to be decay, if it's between 0 and 1. And that kind of lets me see if the graph's going to be going up or if the graph's going to be going more like this with growth or more like this with decay. So we're going to go back over some of the things that we did on Monday, but we're also going to do some more with the graphing, actually getting some values. So after we get done today, you are going to be able to graph using a chart, which is going to be second and graph on the calculator. Okay, we did some of that on Monday, talking about instead of having to plug in an individual number for everyone, if I plug in the equation and do second graph, I'll get all the values for me. Or if we don't have that option, how to graph using a table if I have to do it manually, or if I have to do it with my own little handheld calculator that doesn't have all the fancy stuff that sometimes the graphing calculators do. So that's kind of our goal today, is to look at that, and then we'll kind of set up some of the problems and work them out. So, and just a reminder, we talked about this on Monday, anything that grows or decays by a fixed percent or regularity, whether it's 5%, doubles, whatever it happens to be, is going to have growth or decay. So, when I go to graph these, okay, this first one we'll do just using the regular calculator and using the graphing function. So, let me get the calculator up here. Okay, get that cleared out. We're going to go to the y equals in the upper left-hand corner, and that's going to get me this screen. Okay, so press this button if you haven't, and then we're going to type what I see right here. So 1 times 2, I'll just use the parentheses, and to go to the x exponent, I can't just hit x. I hit this little up arrow, this thing called a caret. That's my exponent button right here, right below clear. And then the button right next to alpha, you see the first letter there is x. If I hit that, I'll get the x. Okay, so this, what my finger is pointing to, and what you see on the calculator screen is one and the same. So let's look and see what the picture looks like, just to be interested here. Okay, I get an upward curve, which would tell me it's growth. Okay, because here, my b value, which is what determines growth or decay, is 2. And that's why this is going up to the right. And that's something important for us to know, because if I don't have the calculator, I need to be able to get a mental picture of what this should look like. So how am I going to actually graph it? If I hit second graph, I get a table. So second graph for the table. And then I can just use those values to graph this, to plot my points. So I have a point at 0, 1. let me zoom in a little more here, make this a little easier to see. So then as I work my way down, I'm at 1, 2, and you can really get by with just doing like 3 or 4 points. I just like doing more as long as they fit on my graph. And I think this will be the last one that's going to fit. And so once I get those dots in, just connect the dots. And that's all there is to this. Again, if I've got the calculator, it's worth my while when I'm in class to kind of get this done. Well, what if I don't have a calculator? What if at least I don't have a fancy schmancy one?
You have that one download site.
Yep, and I'm actually going to do that at the end of the lesson today. I'm going to show you on my website, you can actually, this calculator I'm using on the screen right now, you can get on any computer. It's free, it's easy to do, it's nothing too hard to work through. So I'll refer to that back here in just a little bit. But for now, I'm going to shrink this down. Well, actually, I'm going to get out of here, then shrink it down. What if I don't have a fancy calculator? You know, what if I'm riding in the car, I'm somewhere, I don't have access to one of these? What am I going to do? Here's what I'm going to have you do. We're going to make a quick chart, and we're just going to put in some values. Let's even just say to 3, okay? And I'm going to let a regular calculator help me out with this, because there's usually somewhere we've got access to a regular calculator. So let's just say here's my Joe Schmo calculator. I don't have the graphing function. What do I do? I'm going to take this, and I'm going to type in what I have, except when I get to the exponent part, every calculator's got an exponent button. And then I'm just going to plug in the first x value that I have. So I'll have 2 times 3 to the 0. And whatever answer I get, I'm going to plug in the y side. So for those 4 values, the only thing I'm going to change is the exponent each time. So you're noticing it's not taking me a real long time, even doing it manually. Okay? And the only thing that's changing is my exponent, this x value, and I'm just using the values that are here. And usually by the time I get to that 4th number, I'm going to start getting numbers that are a little ridiculous, that aren't going to fit on my graph. So all I'll do at this point is take the ones that do fit. So 0, 2, 1, 6, 2, 18. That last one's not going to fit. And play connect the dots, and I'll see that it's got growth. And I already knew that for this particular one because my b value was 3, which is greater than 0. So I knew it was going to be growth. And both of these graphs go up to the right, which is signifying of growth, okay? How things will get bigger as they go to the right. So this may be like bacteria that are growing in size. It could be lots of different things. But again, table, manually, neither of them are too bad. So as I flip over, we're going to take a look at a couple of problems and what decay would look like. Well, again, how do I know it's decay? If my b value is less than 1, 1/2 is definitely less than 1, that's going to be decay. So again, we'll do one of each, just so we can kind of keep getting practice with how this works. So we'll do the table on the first one. So again, to get here, I just hit y equals, and I'll clear out what used to be there. And I'm just going to type in what I see. And again, divide will be like my fraction button. And again, this x button here next to alpha is where I get my variable. So 1 times 1/2 to the x. They're the same. So let's just peek for a second what this is going to look like. Okay, you notice that goes down to the right. That's what decay looks like. Okay, it gets smaller and smaller. That could be the value of a vehicle. It could be, I don't know, as you're eating things, all right? But if I want the chart, I hit second, graph, and I can start plotting those points. So I'm like, okay, ooh, they get decimally on me. Now let's go up a little ways. Let's see. Notice how as I go into the negatives, the numbers get a little bigger. That might be a little easier to graph, so I'm going to actually start in the negatives this time. I want to fit as many as I can that it'd actually be on my graph as I put them in. Because I want to actually be able to see that decay occurring. Because once we start going into decimals, that's getting kind of small. So this just comes down and gets smaller. So down to the right is going to be smaller. I can visually see that. Again, I'll just take them straight from the graph. So just like we did last time, we're also going to take a look. Let me shrink this down for a second. And what can I do if I don't have the graphing calculator available? Now, I'm not always going to get myself into a situation where I'm going to be thrilled with the numbers that I get out. Because I noticed when I had decay here that my numbers got really small in a hurry. So maybe this time, let's see. Well, let's try some of these before. I may have to do some changes, but let's see what happens when I use the 0, 1, and 2 here again. See if we see a pattern develop. All right. So I'm going to type in what I see here. So I got 2.4, and now I'm going to start running these values. All right, so 0. Okay, so that's 2. Okay, that's not bad. Let's see what happens when I get 1 plugged in here. Ooh, I'm getting decimals already. Okay, this is going to get really small, so maybe I need to head the other direction. So I'm going to make an adjustment. I wish I had drawn this a little higher so I wouldn't have to do it this way, but what if I start going into some of the negative numbers? Will the numbers start to get bigger? Well, let's play with it. Because I actually want to have values that I can see. So let's try -1 out, see what happens. And again, you've got to use the negative, the white button here, not the minus button. Ooh, 5, I got a whole number. Okay. Let's keep going into the negatives here and see if we keep getting values. Okay. That's probably enough numbers, actually. So let's see what we got here. At 1, we were a little below 1. At 0, I was at 2. At -1, I was up to 5. And at -2, I was all the way up to 12.5. And again, I get my decay. Okay. A little bit sharper. But again, you've got to play with the numbers a little. If the positives start, once you start seeing decimal numbers showing up, really tiny numbers, I'd head the other direction, because otherwise you're not going to really be able to see what's going on. So once I get those in, and I get those graphed, then I kind of start to look and I'm like, okay, my B value here was 0.4. That's less than 1. 4/10 is less than 1. And again, even if I wouldn't have seen a picture of the graph, I know what the graph's going to look like already. When it's going down, it's going to be decay. So when I bump up a little bit, the graph's going down to the right, which is decay. What I also found, and I knew this from before because we talked about it at the beginning, my B value, okay, the number in the parentheses, determines whether it's going to be growth or decay. Because again, if it's greater than 1, it's going to be growth. If it's between 0 and 1, it's going to be decay. It'll never be a negative number inside, because that just doesn't work. And just to kind of reinforce that, to let you see, I'm just going to put this a little bit. There we go. So when I get with a growth function, when b is bigger than 0, and the x-valued exponent is positive, the graph will be getting bigger. It'll be growth. But if my b value is between 0 and 1, so it's like a fraction type thing or a decimal, but x still is positive, the graph's going to be decreasing or decaying, is what's going to be going on with those. And we're not going to go crazy here with a bunch of these. We're just going to do a couple more examples here, and then we'll work on some of the homework questions here and kind of get you a start. So we're like, okay, we figured out what's going to be growth and decay. We figured out how to do it on the graphing calculator. We figured out how to do it with a regular calculator. You know, what's there left to this? Well, doing a little recognition without having something else. So like, for instance, on A and B, we've got like pictures of a calculator screen. In A, is that growth or decay? If your graph's going down to the right, which one is it? It's decay. So down to the right is going to be decay. Well, and then I guess that kind of means that up to the right is going to end up being growth. Okay? It's as simple as that when you're looking at a picture. Well, what if I don't have a picture? What if I just have an equation like the ones down below that? So like these guys. The only thing I care about in all of these is that b value, that number that's being taken to the x power. That tells me everything I need to know. Now be careful on C. Is this going to be growth or decay? Growth, because if I punch 3 divided by 2 into the calculator, that's actually 1.5, which is greater than 1. Okay, and I shouldn't have to type this into the calculator and look at the picture to be able to figure that out. What about the next one? Okay, growth again. 1.2 is bigger than 1. So if b is greater than 1, again, the number with the x exponent, it's growth. You're like, dang, Hardy, you're making them all the same. Okay, here my b value is 2, greater than 1. So it's growth. But then my last two, yeah, 1/4 is definitely less than 1. So my b value would be 1/4, which is decay. And then 0.5 is also less than 1. Okay, which means it's going to be decay. So when we're looking at these, we're almost set. If you were looking, because some of you will ask me on a regular basis, well, when does this ever come into life examples? How's this going to work? Well, I can give you some examples of each. Okay, exponential growth would be like if you have something at an interest rate that you're making money at, you can see how much that's going to be over the next month, year, 10 years, whatever it's going to be, and look forward. Okay, that's how I actually have interest calculators that do that. Or also, the appreciation of an investment. It might be a classic car. It might be, some collectible that you buy or something like that. If there's a set rate that normally something like that increases in, that would be exponential growth. It would keep increasing in value. Now, not everything goes up in value, though. Some things you know, if you have decay, there's certain type of bacteria that over, 10 minutes may decay, or over an hour, or over a longer period of time. Back when nuclear energy was first becoming part of things, they always talked about how long does it take a nuclear isotope to decay to where it'd be safe. Okay? Or something like depreciation of a car. Some of you may have heard, the minute you drive a car off the lot, it loses 18% of its value. Okay? So over time, cars, most of them, not all, most of them end up depreciating because they break down and kind of get older. So that's something else we could put into a chart or a graph that would look like this. So the last thing we're going to look at. All right. We are, let me flip over here. We're going to do some real general examples here at the top, and then we're going to apply it to the two at the bottom, and we're going to be done. So last page here. All right. General equation for exponential growth. We keep staring at this y equals a times bx. Okay, one more time. A is the initial amount I'm starting with, whether it's money, whether it's items, whatever it happens to be. As long as b is greater than 1, we know it's growth. But then come the two parts we haven't talked about a whole lot yet. You're like, what do you mean, then b? We just said what b is. It tells us if it's growth. B itself is going to be my growth rate. Okay? And that's always going to be 1 plus the percent that I'm working with. So if I see the number 1.05 in there, okay, my growth rate, so example, if I have 1.05 to the x, that's the same as having 1 plus 0.05, which means my growth rate is the 0.05. It's 5%. Okay, it wouldn't be 105%. Wouldn't be 1.05. It would be, what am I adding to the 1? What's this value? And then R, which should be X, and I apologize for that, is the amount of time that's going on. Whether I want to know a year, 10 years, whatever it happens to be. And then for decay, a lot of it's the same except for one small part in the middle. A is still my initial amount. Then I notice again, I got a little too copy happy. If b is between 0 and 1, not greater than 1 again, or it'd be growth again, that's going to be decay. So if it's decay, instead of a growth rate, it's a decay rate. Yeah, and instead of being 1 plus the percent, it's 1 minus the percent. Now decay gets a little bit trickier. So for instance, let's say I've got something that says 0.94 to the x. I've got to figure out 1 minus what gets me to the 0.94. So if I play around a little, I find out that's 0.06. And whatever that number is that I'm subtracting as a percent would be my decay rate. So if it's less than 1 under here, I've got to figure out what subtracts. It's sort of like doing a mini algebra problem. And again, x is going to be my amount of time. And again, having stuff like this would be really handy when we get to quizzes and tests to kind of let you see how this is all working together. So when I get to here, when I get to the actual examples, so I want to make sure we kind of see how this is working. All right, Identify the initial value, the growth or decay factor, the growth or decay rate of the exponential function. Holy cow. Okay. Again, all the info I need is right in the parentheses. Is this first one going to be growth or decay? Is the value greater than or less than 1? It's growth because my b value is greater than 1. It's 1.8. The initial value, or the initial amount that I started with, is 3. I started with 3 of something. So now, here's where these things kind of all start to go together. Okay, these two things kind of are different ways of saying the same type of idea. So I know that this is going to be 1 plus 0.8 because I'm always looking, when it's growth, I'm adding something to it. So here is the question. For my rate, I need 0.8 as a percentage. And to get 0.8 as a percentage, anybody know what that is? I can just multiply by 100 and find out that my growth rate would be 80%. Okay, but it's the 0.8 that's that part. So even if I did it on the next one, still going to be growth because my number's still bigger than 1. And that's always found in the parentheses. My initial value, what I start with, is always what it's at the beginning of the problem. And just like before, whether it's growth or decay, it's always 1 plus or minus something. And since this is growth, it's going to be plus the 0.04 that we tack on at the end. Yep. And here, when I multiply by the 100, my growth rate would be 4%. Because again, I'm just taking that plus number and turning it into a percentage by timesing it by 100. So we haven't done a decay. I want to do one decay, and then we'll be ready to tackle this. So let's tackle number 3 here at the top of the next one. All right. My b value is 0.8, less than 1, lets me know it's decay. My initial value still is just the number in front, which is 9. Now here's where it gets tricky. Because I know it's minus. 1 minus something gets me 0.8. Now if I'm not sure how to figure that out, here's just a suggestion. If I want to find that number, I could do 1 minus that value and help me figure out, oh, well 1 minus 0.2 is 0.8, so that's what my factor would be. And then my rate would be 0.2 times 100, which means my decay rate's 20%. So there's a little more work when it's decay. I will not lie, I will not say that it's not. And then the same thing on this last one. We'll just do the decay and growth factor. 1 minus something gets me the 0.94. Whoops, let me get that in the screen. Again, literally do 1, yep, 1 minus 0.94 would be 0.06. And times that by 100 to get my rate of decay. So, here is what our task is ahead of us. Keep this in a safe place. This would come in very handy on a quiz or a test. And we are going to take a look at what we are doing in the homework today. Now, we are going to stress the graphing portion of it today. Then we'll kind of go from there. So, all right, story problem. We get you started with a chart here. Denise's brother Daniel bought 2 fish. The salesperson at the store said they would triple in number every month. Complete the chart below to show how many fish Daniel has each month and then graph it. So you'll notice I start with 2. Okay, so that'd be my initial value. And then 3 is what we keep multiplying by. So as you go towards each month, you take whatever you had in the previous month and times it by 3. Whatever you had the previous month and times it by 3. And this number starts to get kind of ridiculous. But the reason to show you this is when you get to the last one, and this is what we talked about more on Monday, and it says number of months n. When you go to make your equation, we remember that this is y equals a times b to the x. Well, what did I start with? Well, I started with 2 fish. So that's my initial amount, or my a. And then my growth factor is the fact that it keeps going by 3 each time. That's how I come up with my expression. And that's the number of fish I would have at the end. But me being able to figure out what the equation is helps out immensely. So then I get to here and I'm like, okay, I see I'm supposed to graph this, and that's all fine and good. But my graph isn't big enough to go from 2 to 486. So I'm going to have to come up with something else. So whatever I feel like making each of these lines worth, so I don't know, let's see. If I do 25, is this going to work? Oh, let's try it out. I'm going to be close. And I'm going to come up short. Well, that's okay. I'll make this work out for me. Now, if you wanted to do it by hundreds or 50s or whatever you wanted to do is fine. And then I'm just going to start plotting these points. Now, these first two are going to be really close together because if I'm going by 25s, I mean, I'm not even in the first line yet. I'm getting close, though. 3's all the way up to 54. 4's up to 162. And then 5 we're through the chart roof here. That's a lot of fish. 5 months later, he's almost got 500 fish. Yowzers. But that's how these end up working. Okay? We're going to form the equation at the end by just continuing to multiply by the number that they give me there. Okay? That's how these last two on the front are going to work. Once I get those two set, there's one other thing. When I flip over to the back, you're like, wait a minute. Linear, exponential, or neither. What? Okay. When I get to this, linear, okay, exponential means my exponent is x. We've been talking about that today. If it's linear, my exponent is going to be 1. And neither is if it isn't x or 1. So for instance, when I look at number 4, my exponent's an x. Okay, oops, I got to call it exponential, not growth. Even though it would be. So if I see an x for my exponent, it's exponential. If I see a 1 for my exponent on something, that's linear. Okay, so that's the kind of little catch here. If I see exponents that aren't x or 1, those are neither. That'd actually be a quadratic, but we're not worried about that. So those are the 3 types that are up there. But I'm basically just looking at exponents. If I see an x, whoop, exponential. If I see something to be an exponent of 1, whoop, linear. And if I see any other weird numbers, 2, 3, 4 as an exponent, those are going to be neither. And then finally, we're going to determine at the bottom here if each table of values is linear, makes a straight line, is exponential growth or decay, and then graph it. So, for instance, I would probably plot the points and graph it before I tried to figure it out. That's just me. So like here, let's see. How many lines do I have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, I can go by 2s here. So I'll line this up along the bottom. And if I count by 2s up the side of my graph, and again, that'll adjust. Sometimes it may be 10s, whatever you want to make it. I'm going to plot my points. 110, 214, 318, 422, and 526. To me, that looks an awful lot like a straight line. So that would be linear. It's a line. Duh. So if it doesn't make any sort of a curve, if it makes a straight line, it's linear. If you plot them and then it starts to make a curve when you play connect the dots, well, then it's exponential, and it might be growth, might be decay, depending on what you're doing. So your task is to knock out the rest of these, okay, using the examples we've got here. And like I said, tomorrow we're going to do a little review. We're going to get you some more practice at graphing these with the calculator, and we're going to do a mini quiz, kind of seeing with exponent rules and some of those things. I'm going to put a little twist on the quiz, but I won't tell you about it till tomorrow. You'll like the twist to it. It's going to be one of those quizzes where nothing but good things can happen to you. Oh, I'll just tell you. The quiz tomorrow is going to be what I like to call a replacement grade, which is if you've had a bad quiz or a test or something like that, and you're like, oh, I didn't retake it, I didn't know what I was doing. This quiz that we do tomorrow, if it improves your lowest quiz grade, I will replace the old quiz grade with the one we do tomorrow. Now, if it goes, well, then I'll just pretend it never happened. So it's one of those things where it's a no-lose situation for you. But do finish this up.